Welcome to Race MES. Today, I'm excited to introduce you to our AI-first execution layer for manufacturing, which encompasses rule, action, cognition, and events. This innovative system senses, decides, acts, and learns in real time. This is RACE, an AI-powered, event-driven execution layer. On the left, data ingress connects to everything in the plant, ERP, external context data, and contextualize it. The rule engine applies reusable logic with plant context and emits events, clear, single-state indicators of what matters. Those events flow two ways: to people via dashboards, and to the action engine to run workflows, integrations, executions, and alerts. Alongside, the cognition engine learns from the stream to investigate, predict, and recommend. End-to-end, it's a governed loop: sense to decide to act to learn.
Let us begin promptly with the data sources.
Connection sources serves as a key hub for integrating data, in this case the Aveva data source. The RACE platform allows for the configuration of multiple tenants and namespaces, ensuring secure management of client IDs and keys for production assets. RACE provides an overview of all available streams, enabling users to select specific ones for monitoring. Once you have added the enabled streams to the monitoring engine, you can access the stream monitoring page to verify their status, quality, and the values that should correspond with the various sources.
The rule engine is a versatile framework for defining universally applicable logic, organizing rules by business domain with reusable templates.
This document outlines the rule management configuration, which is designed to establish logic once and apply it universally across various contexts. Packages are organized by specific business domains. For instance, we have developed packages for manufacturing operations, energy management, and safety. These packages are released periodically, allowing us to create as many as necessary to align with business priorities and market demands. Templates serve as encapsulated reusable patterns with placeholders, each mapped for runtime execution to corresponding monitored data points. Notably, templates can be utilized within the RACE lightweight framework, which operates on premises to ensure business continuity for critical operations. Within these templates reside rules. Each rule defines conditions, severity, categories, and optional contextual enrichment, all while incorporating built-in auditing and versioning capabilities. When a rule's conditions are met, it generates an event, enhanced by additional contextual data provided through the variable enrichments. This mechanism facilitates advanced analysis powered by artificial intelligence. When conditions are met, traceable events are generated on the event wall and can drive downstream actions immediately.
Event is the heartbeat of RACE. Every rule hit becomes a time-stamped, categorized event enriched with context data.
The event wall is the operational heartbeat of RACE. It's a live, scrolling timeline where every rule hit becomes a time-stamped, categorized event enriched with plant context from the ISA 95 model. Color and icons signal severity and category, production, maintenance, quality, utilization, so you spot what matters at a glance.
API calls, microservices, governed, reliable, traceable.
An action is a generic function, typed inputs in, outputs out. Under the hood it calls a microservice, from a simple notification or email, to a compute task, an ERP integration, or a slice of MES process logic. An action consumes a microservice over a REST API. In this first example, we bind an action to a safety risk event when the fermentation tank level crosses a defined threshold. That condition represents a hazard for the area and operators, so the action emails the supervisor immediately. You'll see the call execute, the message delivered, and the result logged back into the event trail for full traceability. In the second scenario, we raise the complexity to stress test the prototype. We simulate process order start, a core manufacturing execution moment. On PO start, an action calls a microservice to generate a lot code. When the lot code returns, it emits a new event that triggers a second action, a microservice to download parameters to the PLC. This is an event-driven workflow. One event produces data, the next consumes it. On the event wall you see the entire workflow execute end-to-end: PO start, lot code generated, PLC parameters downloaded, correlated as a single chain. Every step is timestamped, categorized, and enriched, so in one pane of glass you gain real-time situational awareness across assets and systems. Watch the flow as a living graph. Hover to reveal inputs and outputs, loops, dead ends, and bottlenecks. Filter by package or template to see an exact map of which rules executed, which actions fired, and which events were produced. With one click you pivot into detailed views for rules, events, and actions. Run impact analysis. If I change this workflow, what result will I get? With version tags and full audit at every step. It turns complexity into clarity and curiosity into control, so you can go from why to what next in seconds.
Here we meet Race AI, data control, assistance, agentic missions, and prediction.
With the Race MES system, we can configure mainstream AI providers and decide how they operate. Let's start with Race AI's first capability, data control, powered here by a standard GPT model. We can configure multiple chat endpoints and expose them in the contextual menu. I'm opening chat with my MES data. All MES facts are pre-serialized and AI-friendly: assets, streams, templates, instances, events with enrichment, and KPI snapshots, so the assistant can reason over governed data without SQL or ad hoc scripts. The chat runs under guardrails. A scope system prompt limits topics and actions, provider and model are selectable, and responses are grounded on our plant model and event wall, not on the open web. Credentials, PE, and secrets are masked. Every exchange is logged and auditable. Chat is not a dead end. Suggested actions can open an action pre-filled with parameters, or create a cognition mission for deeper investigation, keeping the operator in one flow. In short, data control turns natural language into a governed control surface over MES data, surfacing issues, explaining context, and proposing next best actions in seconds. Now let's talk about the assistant, and how it differs from GPT chat. With chat, we expose governed MES data to a model: events, the plant model, context, and enrichment. You ask questions, it reasons over what it understands. The assistant goes further on for context, investigation, analysis, report, or troubleshooting, about assets, rules, actions, and events. It's specialized and mission-oriented. I can spin up as many assistants as I need and scope each one tightly, to a specific equipment, a process area, or even a safety scenario. If I ask for an investigation, it must run the log inspector, correlate recent events, and check rule executions before answering. If I ask for a report, it must use the charting report generator to return structured visuals, not free-form text. For safety workflows, it can be required to run the checklist and notification tools before it considers the task done. Let's finish with a look ahead. Event prediction in Race MES. Using AI, we ingest historical events over a chosen time window and forecast what is likely to happen in the next hours, or any horizon you select. This is powerful for safety, prevent hazards, execution, avoid scrap or unplanned stops, and energy, curb runaway consumption. The model learns recurring patterns across millions of signals and events, then outputs a ranked list of expected events, each with confidence, time to hit, and leading indicators. You can run it on demand or on schedule, and every prediction carries traceability: what data it used, why it believes a spike is coming, and which assets are implicated. Thank you for your time and attention. With Race we turn raw signals into decisions, actions, and learning, in minutes, not months. We've shown how rules, actions, cognition, and events come together to deliver real-time visibility, governed workflows, and AI that investigates, acts, and predicts. Thank you.